Designed for piercing and blanking, the construction, operation, and maintenance of piercing and blanking dies can be greatly facilitated if designers of the parts is to be fabricated keep a few simple rules in mind. 1. Diameters of pierce holes should not be less than the thickness of the material, with a minimum of 0.3 mm or 0.025 inch. Smaller holes can be made but with difficulty. 2. The minimum distance between holes or between a hole and the edge of the stock should be at least equal to the metal thickness. 3. The width of any projection or slot should be at least 1 times the metal thickness and never less than 2.5 mm. 4. Keep tolerance as large as possible. Tolerances below 0.075 mm or 0.003 inches will require shaving. 5. Arrange the pattern of parts on the strip to minimize scrap. Bending. The plastic deformation of metals about a linear axis with a little or no change in the surface area. Multiple bends can be made simultaneously, and if it is done by a single die, it's called forming. True bending is when each axis is linear and independent of others. Bending. Drawing or stretching is made when axes of deformation are not linear or not independent. Simple bending causes the metal on the outside to be stretched while the inside is compressed. The location in which a metal is neither stretched or compressed is called neutral axis. Angle bending. Bar folder can be used to make angle bends up to 150 degrees in sheet metal under 1.5 mm thick. Press brakes. For heavier sheets or for more complex bends in thin material, these are mechanical or hydraulic presses with a long, narrow bed and short strokes. The metal is then bent between interchangeable dies that are attached to both the bed and the ram. Seaming, embossing, punching, and other operations can also be made here. Designed for bending. Relationship between the minimum bend ratios relative to thickness and the ductility of the metal being bent, as measured by the reduction in area in the uniaxial tensile test. Designed for bending. Primary concern. Determining the smallest bend radius that can be formed without metal cracking, or also known as the minimum bend radius. This value is dependent on both the ductility of the metal, measured by the percent reduction in area observed in a standard tensile test, and the thickness of the material T varies with material ductility. An extremely ductile material is required to produce a bend with radius less than the thickness of the metal. Bends should be designed with large bend radii for easier forming. If the punch radius is large and the bend angle is shallow, large amounts of springback are encountered. When bend radius is greater than 4 times the material thickness, the tooling or process must provide springback compensation. If the metal has experiences of previous cold work, make the bend axis perpendicular to the direction of previous working. This is related to the mechanical loading applied to the weak-oriented inclusions. Designed for bending. Another concern is determining the dimensions of a flat bank that will produce a bent part of the desired precision. Metal tends to thin and lengthen when it is bent. The amount of lengthening is a function of both the stock thickness and the bend radius. The tolerance of bent parts should not be less than 0.8 mm. Parts with multiple bends should be designed with most or all of them with the same bend radius to be able to produce tooling costs and setup time. Air bend, bottoming, and coining dies. Bottoming dies compact and compress the full area within the tooling. They are designed for a specific material and material thickness, and they form bends of a single configuration. The angle of the resulting bend is set by the geometry of the tooling, adjusted for subsequent springback, and the inside bend radius is that machined on the nose of the punch. Air bend dies produce the desired geometry by simple 3-point bending. It can accommodate a variety of materials in a range of material gauges and requires the least force of the 3 options. bottoming or bending and coining. The resulting angle is controlled by the bottoming position of the upper die. A single set of tooling can produce a range of bend geometries from 180 degrees through the included angle of the die. If bottoming dies continue to move beyond the full contact position, the thickness of the bent material is reduced. Because of the extensive plastic deformation, the operation becomes coining, bottoming with penetration. Hard curvature using forming rolls. Roll bending machines usually have 3 rolls in the form of a triangle. They are available in wide range of sizes. Some are even capable of bending plate up to 25 centimeters thick. Left, schematic of the roll bending process. Right, roll bending of an I-beam section. Note how the material is continuously subjected to 3-point bending. Draw bending, compression bending, and press bending. Bending machines can also utilize clamps and pressure tools to bend material against a form block. In draw bending, the workpiece is clamped against a bending form and the entire assembly is rotated to draw the workpiece along a stationary pressure tool. In compression bending, bending form remains stationary and the pressure tool moves along the surface of the workpiece. Press bending utilizes a downward descending bend die which pushes into the center of material that is supported on either side by wing dies. The flexibility of these processes are limited because a certain length of the product must be used for clamping. Draw bending, letter A. Letter B, compression bending. For letter C would be press bending. Tube bending. Key parameters are the outer diameter of the tube, the wall thickness, and the radius of the bend. As the outer diameter increases, the wall thickness decreases, or the bend radius becomes smaller. The outer of the tube tends to pull to the center, flattening the tube. A common method for resolving this problem is packing the tube with wet sand, produce the bend, and then remove the sand from the interior. Flexible mandrels have now replaced the sand. Roll forming. This process involves progressive bending of the metal strip as it passes through a series of forming rolls at speeds up to 80 meters per minute or 270 feet per minute. Seaming and flanging. Seaming is a bending operation that can be used to join the ends of sheet metal in some form of mechanical interlock. Flanging involves a rolling operation on sheet metal in essentially the same manner as seams. Seaming and flanging. Seaming machines range from small hand-operated types to large automatic units capable of producing hundreds of seams per minute. Common products are cans, pails, drums, and other containers. Straightening, flattening, or leveling. The objectives of these processes are the opposite of bending. Roll strengthening or roller leveling subjects the material to a series of reverse bends. Method of straightening rod or sheet by passing it through a set of straightening rolls. For rods, another set of rolls is used to provide strengthening in the transverse direction. The rod, sheet, or wire is passed through a series of alternation upper and lower rolls with progressively decreased offsets. This produces deep bends at the entry, decreasing to little or no bend at the exit. Sheet material can also be strengthened by stretcher leveling. With this process, finite length sheets are gripped mechanically and stretched beyond the elastic limit to produce desired flatness. Drawing in Chapter 16 processes that reduce the cross-section of material by pulling it through a die. Drawing in Chapter 17. Family of operations where plastic flows over a curved axis and the flat sheet is formed into a recessed three-dimensional part with a depth more than several times the thickness of the metal. They can be used to produce a wide range of shapes, from small cups to large automobile and aerospace panels. Drawing and stretching processes. Drawing. Metal flows inward as it is forced to change shape. This allows the thickness of the material to remain relatively constant or even thicken. stretching, restrict the compensating movement, and the increase in surface area is accompanied by a decrease in material thickness. During this process, tensile loads are present and the material is at a great risk of failing. Spinning. Cold forming operation where a rotating disc of sheet metal is progressively shaped over a mill form, mandrel, to produce a rationally symmetrical shape such as cones, hemispheres, cylinders, bells, and parabolas. During spinning, the form block sees only localized compression and the metal does not move across it under pressure. Here in Figure 1732, progressive stages in the spinning of a sheet metal product. There's the final shape, steps in spinning, original blank of sheet metal, follower held in tailstock, roller, and form attached to headstock, spindle. Usually considered for simple shapes that can be directly withdrawn from a one-piece form. Rentant angles for complex shapes can be spun over multi-piece offset forms. A recent modification of spinning will be laser-assisted metal spinning. Its beam is focused directly ahead of the roller to heat and soften the material. The rod, sheet, or wire is passed through a series of alternation upper and lower rolls with progressively decreased offsets. This produces deep bends at the entry, decreasing to little or no bend at the exit. Sheet material can also be strengthened by stretcher leveling. With this process, finite length sheets are gripped mechanically and stretched beyond the elastic limit to produce desired flatness. Drawing in Chapter 16 processes that reduce the cross-section of material by pulling it through a die. Drawing in Chapter 17, family of operations where plastic flows over a curved axis and the flat sheet is formed into a recessed three-dimensional part with a depth more than several times the thickness of the metal. They can be used to produce a wide range of shapes, from small cups to large automobile and aerospace panels. Drawing and stretching processes. Drawing. Metal flows inward as it is forced to change shape. This allows the thickness of the material to remain relatively constant or even thicken. Stretching. Restrict the compensating movement, and the increase in surface area is accompanied by a decrease in material thickness. During this process, tensile loads are present and the material is at a great risk of failing. Spinning. Cold forming operation where a rotating disc of sheet metal is progressively shaped over a mill form, mandrel, to produce a rationally symmetrical shape such as cones, hemispheres, cylinders, bells, and parabolas. During spinning, the form block sees only localized compression and the metal does not move across it under pressure. Here in Figure 1732, progressive stages in the spinning of a sheet metal product. There's the final shape, steps in spinning, original blank of sheet metal, follower held in tailstock, roller, and form attached to headstock, spindle. Usually considered for simple shapes that can be directly withdrawn from a one-piece form. Rentant angles for complex shapes can be spun over multi-piece offset forms. A recent modification of spinning will be laser-assisted metal spinning. Its beam is focused directly ahead of the roller to heat and soften the material.